Let me start recording. So just remember, for quiz 14, everybody got credit for quiz 14. So pretty much we're over quiz 14. So for today quiz, you're going to be taking quiz number 15. And also for the activity, we're also one activity ahead. So whichever activity I already gave you full credit for, pretty much that's the activity we're going to start today. And I'll go over which activity we're going to start today a little bit later. So just remember, we're a day ahead. So for the quiz, everybody got full credit for quiz number 14. So for today quiz, you should be taking quiz number 15 today. And then tomorrow you take quiz 16, so on and so forth. All right, any question in regard to that? All right, sweet. So just remember, we're in week 5. So pretty much all the information you're gonna find in week 5. So if you go to week 5, you'll find all the lecture notes on week 5 under, I think, lecture notes I put it under. So if you're printing them out or if you're uploading to your tablet or uploading onto your phone, that's where you're gonna find it under week 5. And also just to let you know, pretty much this week is the final week of lecture because all of next week is pretty much going to be review for test number 3. And then it's going to be review for your final. So just know that this week is the final week of lecture. And then next week, pretty much you have your third exam on Tuesday. And then you're going to have your final, which should be on, I think on Thursday or Friday. I'll check that later. But yes, now next week is pretty much going to be all review and exam. This week is going to be all lecture. All right, so let me go ahead and just show you my notes. All right. So just to kind of recap on Friday, we went over the Z distribution. And you want to use the Z distribution anytime sigma is given. So sigma is given. Because if sigma is given, pretty much Z distribution can be the best distribution to use for that distribution. So if sigma is not given, that's what we're going to go over today. So if sigma is unknown, so if sigma is unknown, what we're going to do, we're going to use something called the T distribution. So today we're going to be working purely with the T distribution. So if sigma is unknown, that means we're using sample standard deviation. So we're going to be using sample standard deviation. So if they don't give me population standard deviation, they give me sample standard deviation. That's how I know that we're using the T distribution. So for this one, you have to be careful. You have to see, where does the standard deviation come from? Does it come from the entire population or does it come from a sample? So let's go over some key thing about the T distribution. So let's go over the first one. If you look at it, it says the T distribution is different for different degrees of freedom. So for the T distribution, it has something called degrees of freedom. So the way that we get degrees of freedom, you do n minus 1. So say if your sample size, and remember n represents sample size. So if n is 15, if you want to find what degrees of freedom is, you do 15 minus 1 and you get 14. So for the T distribution, it is never the same because depending on your sample size, it should change slightly a little bit. So depending on how big or how small your sample size is, you should have a different T distribution. All right. So step number 2, or part number 2, said the t distribution is centered at 0 and is symmetric about 0. So if you kind of remember for the z distribution, if we have the z value, you put the middle with 0. So same thing for the t distribution. The middle will be 0 unless otherwise stated. But if pretty much we know we have a t value, pretty much the middle will be 0, and then it should be symmetric about 0. So step number 3 says the area under the curve is 1, so it's equal to 100%. And it says the area under the curve to the right of 0 is equal to the area under the curve to the left of 0, which is 1/2. So pretty much what that one is explaining, if you cut this in half, half of it will be to the right, half of it will be to the left. So that was step or part 3 saying. It's saying if you cut it straight down the middle, which 0 is the middle, that half of the probability should be to the left of 0, half of the probability should be to the right of 0. All right. So part 4. So it says as t increases or decreases without bound, the graph approaches but never equal to 0. So that's pretty much just going to so when it's talking about the bounds, it is talking about these over here. So it is saying that those bounds should never touch this line. So once it's touched that line, that's saying that it's equal to 0. So you're saying that, hey, the further and further away we get, it's still not touching 0, but the probability of it happening does become lower and lower. So you're saying that the probability of something will never equal to 0. It will equal something very close to 0, but it should never equal to exactly 0. All right. So number 5, it says the area in the tail of the t distribution is a little bit greater than the area in the tail of the standard normal distribution because we're using as a s as a estimate of sigma, thereby introducing more variability into the test statistic. So you kind of remember, like for this one, since we're using S and not sigma, sigma is the population standard deviation. The population standard deviation is way more accurate than sample size, which is S. So because of that, pretty much the t distribution, essentially they have fatter tails. And the reason it has fatter tail is because essentially since we have a sample standard deviation, we know it is more or less accurate. Since it's less accurate, we do know that the t distribution like will have more probability going to the left or going to the right of the tail. All right. So the last one, it says as the sample size of n increases, the density curve of the t gets closer and closer to the standard density curve. The result occurs because of the sample size n increases, the value of s get closer to the value of sigma by the law of larger number. So if you kind of look at my drawing right here, essentially we have a bunch of different degrees of freedom. So we have degrees of freedom of say 1. We have degrees of freedom of 2, which is this one. But also if you look right here, if you look at the black that's dash, that's the normal distribution. So if you look at it as the degrees of freedom get bigger and bigger and bigger, it becomes more and more approximately normal. So eventually, because the degrees of freedom, like eventually will just become a normal distribution. Because if you kind of remember the law of large number, you said like, hey, the bigger your sample size, the closer and closer we should be getting to the theoretical probability. So for this one, the bigger our sample size get, the closer and closer we should be getting to that theoretical population standard deviation. So you're saying if our sample size is big enough, eventually our degrees of freedom formula and our normal distribution will essentially become the same. All right. So those are it for some statistic about our t distribution. Any question in regard to that so far? All right. And if you remember from Friday, we still have the central limit theorem. So the central limit theorem says if n is greater than or equal to 30, we say our distribution is, we say that our distribution is to be approximately normal. Any question before I move on? All right. All right, so this is how we're going to calculate the t value. So if you look at it, it says x bar minus mu of x bar, but if you look right here, mu of x bar is equal to mu, and you divide that by sigma of x bar. And if you look right here, here goes sigma of x bar. But if you notice, for sigma of x bar is different from last Friday, because last Friday we had, well, we had sigma divided by square root of n. In this case, since we don't have sigma, we're using s, so we do s divided by square root of n. All right. Any question in regard to that so far? All right.
No.
So let's go ahead and do this example. So it says find the probability that a compute t from a sample of size 20 will fall. Okay, so if you look right here, they're telling us these are t values. So we want to find the probability t is greater than 2.093, probability that t is less than 1.729, and the probability that t is between 1.729 and 2.093. So they already told us they computed t value. So you kind of think about it, they already did this math and they already found the t value. So they found the t value to be 2.093, 1.729, and 1.729 to 2.093. So they already found the t value. So that means our mean is 0 and our standard deviation is 1. So once we go to class count, that's where we're going to put. All right. So before we go to class count, we have to calculate our sample size. Oh, sorry, not our sample size. We have to calculate our degree of freedom. So for this one, what would be my degree of freedom?
Sample size is 20 minus 1.
Yeah. So you do 20, which is your sample size, minus 1. 20 minus 1 would give me 19. So your degree of freedom is 19. All right, so up to I'm going to go ahead and do. Well, before we do that, let's draw this out. So let's do A. So here goes 0. Here go 2.093. So if you look at it, since we want it to be above 2.093, which side should I shade? Should I shade the left side or should I shade the right side?
Left side.
Right side.
Let's try that again. Which side?
Right side.
Yeah, there you go. You want to shade the right side. Because if you look at the symbol right here, if you look at this symbol over here, it says greater than. So greater than, or if you look at this, it says above. So you want to shade the right side. So if that's what we want, what we're going to do, we're going to figure out what's our lower bound, and we're going to figure out what's our upper bound. So for this one, what will be my lower bound?
2.093.
Perfect, 2.093. What will be my upper bound?
Of infinity.
There you go. All right, so let's go over to the t, well, let's go over to class count and do our t distribution. All right, so here you go class count. So what you want to do, you want to go to stats. You're going to go over to distribution. You're not going to use normal distribution, but you're going to use the one right next to it to the right of it. It says t distribution. So let's select t distribution. So if you look at T distribution, it's asking for DOF, which is the degrees of freedom. So we said degrees of freedom is 19. They put 19. So lastly, what we're going to do, since we're trying to find the probability of this degrees of freedom, you put CDF. So now for the lower bound, we said was 2.093. For the upper bound, we said it was infinity. All right, so if you look at that, we get 0.025. So we get the answer for part A to be 0.025. And that will be it for A. Any question on how we got A?
No.
All right, so I'm gonna go back, switch back to my notes, and we're gonna do B. All right, so if you look at B said below 1.729. So if you look at my drawing, I put the middle as 0 because we have the T value already. And what we want to do, we want to shade to the left of it because it says below 1.729, because below means any number below it. So the number that will be below 1.729 should be all the number to the left of it.
Somebody put in a question.
Okay, let me check that question. Thank you. Okay, so in order to do degrees of freedom, all you have to do the formula. Here, let me do it in red. Is n minus 1. So if you look at this one, we got sample size of 20. So you do 20 minus 1, and you get 19. So that's how you get degrees of freedom. All you have to do is get to the sample size minus 1, and that's how you get degrees of freedom. All right. So if you look at part B, so we have the drawing now. So let's try to do the lower bound and the upper bound. So if we do the lower bound, what's the lower bound for this one?
Negative infinity.
Negative infinity.
Yeah, perfect. So we got negative infinity. And if you look at the upper bound, what's my upper bound?
1.729.
Yeah. So that's exactly what we're going to put for the T distribution. So let's go back to. All right. So the degrees of freedom is still 19 because this is coming from the same problem. So we said that it's negative infinity, so we'll put negative. And then remember, for the infinity sign, you just hold the division sign and you get negative infinity. And for this one, the upper bound, we said was 1.729. And if you look what we get 0.94998. So we could just say 0.95. So for our answer for part B, we'll just say 0.95. And that'll be it in regard to part B. Any question for part B? All right, so lastly, we're gonna do part C. If you look at part C, it says between 1.729 and 2.093. So we're gonna put 1.729. And we're gonna put all the way to 2.093. All right, so if I want the probability of 1.729 all the way to 2.093, you get 0.025011. And that'll be it for that one. All right. And that's how you do A, B, and C. Any question for A, B, or C? All right. So let's do a problem. So let's do this first problem. So for this problem, it says, suppose that we randomly select a sample of 64 measurements from a population that has a standard deviation equal to 4. The population mean is 20. So for this one, we have a sample size. So for this one, we have a sample size of 64. And from this sample size, we got sample standard deviation to be equal to 4. And if you look right here, they say the population mean is 20. All right. So far that's given to us. So for part A, what we're gonna do, we're gonna describe the shape of the sampling distribution, the sample mean. Do we need to make any assumption about the shape of the population? Why or why not? So for this one, do they tell us anything about the shape of the population? If-
No.
yeah, so if you look at it, this will be no, because they don't tell us if it's normal or if it's skewed to the left, skewed to the right. They don't tell us anything about the shape of the population. So what we're gonna do for this one, we're gonna do the central limit theorem. So we're gonna do the CLT. So for the CLT, all we have to do check to see if n is greater than or equal to 30. So for this one, if you look at, we set n is equal to 64. So we say 64 is greater than or equal to 30. So is that a true statement? Is 64 greater than or equal to 30?
Yeah.
Yeah, so since 64 is greater than or equal to 30, we could say this is approximately normal. All right. So now that we know the approximately normal, we could go ahead and just find pretty much everything for this one. So for part B, it says find the mean and standard deviation of the sampling distribution of the sample mean. So what we want to do, we want to find mu of x bar, and we want to find sigma of x bar. So for this one, what's mu of x bar?
20.
Yeah, 20. Then what we want to do, we want to get sigma of x bar. In order to get sigma of x bar, you have to do the sample standard deviation divided by square root of 64, because that's your sample size. So if you do 4 divided by square root of 64, square root of 64 is actually just equal to, oops, sorry about that. It's just equal to 8. So you get 4 divided by 8. If you do 4 divided by 8, you get 0.5. All right, so right here we found the mean of x bar to be 20, and we found sigma of x bar to be 0.5. Any question in regard to how I got any of those values? All right, so let's do C. So C says calculate the probability that we will attain a sample mean greater than 21. So what we want to do, we want to find the probability x bar is greater than 21. So in order to find that, we're first going to have to find our t value. So to find t value, we're going to have to do x bar minus mu of x bar divided by sigma of x bar. So if you look at our x bar is 21, because that's the value that we're trying to find the probability. If you look at mu of x is equal to 20, because that's what we found in part B. And then for sigma of x bar is equal to 0.5. Any question in regard to, I got 21 minus 20 divided by 0.5. Okay. So if you do 21 minus 20, you get 1 divided by 0.5. If you do 1 divided by 0.5, you get 2. So when I draw this, we're going to put in the middle 0. You're going to put 2 right here. Because since we found the t value, that's why you put the middle is 0. All right. Everybody good? I got 2 for my t value.
Yes, sir.
All right. So up next, what we want to do, we want to figure out what to shade. So if you look at it, it says it has to be greater than 21. So that means it has to be greater than 2. So you shade the right of 2. And the reason why we're shading the right of 2 and not the right of 21, because remember, we converted the 21 and we converted that into a t value. So now instead of saying 21, we're going to say, what does the 21 represent? Well, the 21 represent as 2, that t is equal to 2. So that's why you put t is equal to 2. So last thing before we go over to class count, we have to find what is the degrees of freedom. So for this one, what's my degrees of freedom if my sample size is 64?
63.
Perfect. And that's, we get it because we do 64 minus 1, so we get 63. All right, so let me do the lower bound and the upper bound, and then we'll go off to class count. What's my lower bound for this one?
2.
Perfect, 2. And then my upper bound will be what?
Positive infinity.
There we go. All right, so now let's go over to class count. All right, so let's delete this. So let's go to stats. Let's go to distribution. And let's do the t distribution. So once again, we have to put degrees of freedom first. So you put 64. This one, we're going to put CDF. And we're going to put lower bound is equal to 2, upper bound is equal to infinity. So our final answer will be 0.0259. So pretty much 0.025. All right, and that's it for part C. Any question in regard to part C? All right, so let's do part D. All right, so for part D, it says calculate the probability that we will obtain a sample mean less than 18. So for this one, we want it to be less than 18. So we say probability that X bar is less than 18. So remember, we already know mu of X bar is equal to 20. We already know sigma of X bar is equal to 0.5. So if we want it to be less than 18, what we have to do, we have to find the t value that corresponds to 18. So we're going to say t is equal to 18 minus 20, and you divide that by your samples, well, your standard deviation of X bar. All right. So everybody got how we get 18 minus 20 divided by 0.5.
Yes, sir.
All right. So if you do 18 minus if you do 18 minus 20, you get negative 2 divided by 0.5. So then if you do negative 2 divided by 0.5, you should get negative 4. So that's our t distribution. So our t distribution in this one is negative 4. So now we're going to go ahead and draw this out. So here goes 0, and here goes negative 4. So if you look at it, it said we want it to be less than 18. So remember, we're not doing less than 18 anymore because I converted the 18 into a t distribution. So technically, we're going to find the probability that t is less than negative 4. So since it's less than -4, we shade this portion over here. So let's see what's the lower bound, what's my upper bound. So what will be the lower bound for this one?
Negative infinity.
Yeah, -infinity. What's my upper bound?
-4.
Perfect. We're on it today. So let's go over to class count and let's enter the. So if we go to stats, we go to distribution, we go to T distribution. Once again, you have to put that as 63. And then we have to put CDF. So for this one, we actually leave the -infinity and we actually change it to -4. So if you look at this one, you get 0.00009. 0.00009. And that'll be it for that last problem. Any question in regard to the last problem? All right, so like one thing you kind of have to notice. Do you have a question, Irvin?
No, sir.
All right. So one thing you kind of have to know is the difference between what we did on Friday and what we're doing right now. For what we did on Friday, if you remember when we went to stats, distribution, and we did the normal distribution, for the normal distribution, it actually let us change the mean and the standard deviation. But if you look at the t-distribution, the only thing allowed to change is the degree of freedom. So whenever you're using the t-distribution, you have to remember that you first have to get the t-value. Once you get the t-value, then you use the t-distribution. But for the normal distribution, you don't necessarily have to find the z-distribution. You can just go ahead and plug in your new mu and your new sigma, and then you do the CDF. So you kind of notice a little difference between the normal distribution, which is your z-distribution, and the t-distribution. All right, so let's try out another problem. So let's go to my notes. All right, so let's go ahead and read this problem. So if you look at it, it says the average length of a hospital stay in the US is mu, which is equal to 9 days. Assume a simple random sample of 100 patients is obtained and the mean stay for 100 patients is obtained. The standard deviation of the sample of 100 patients is 3 days. What is the probability that the average length of stay for the group of patients will be less than 9.6 days? To answer the question, we usually think of the following steps. So before we get to part A, B, and C, first thing you want to do is just label everything. So how many patients did they say they sample?
100.
100, perfect. So we say N is equal to 100. All right, so if you look at this one, they tell us what the average length of a stay in the hospital is. What the average length of the stay in the hospital, what would that be?
9 days.
Yeah, 9 days. So we put mu is equal to 9 days. So here's the part where you have to be careful because remember, there are two different ways that we could do it. We could either do normal distribution on class count, or we are going to use the t-distribution. To be able to decipher which of the two we use, you have to look at your standard deviation. If the standard deviation comes from a sample, you use t-distribution. But if the standard deviation comes from the population, that's going to be the normal distribution. So let's read this sentence right here. So it says the standard deviation of the sample of 100 patients is 3 days. So is this telling me this is the standard deviation of all the patients, or is it telling me this is the standard deviation of a sample?
Sample.
sample, because this telling me this is the standard deviation of the 100 patient. Since this is the standard deviation of the 100 patient, that means we're going to put S is equal to 3 days. All right. But that's it in regard to all of the labeling. All right. Everybody good so far with the labeling?
Yeah.
All right. So
Yes,
let's go
sir.
to part A. Part A says, what is the mean of the sampling distribution of X bar for the sample size of 100? So we want to find what mu of X bar is. So what will mu of X bar equal to?
9.
9, perfect. And that's it for part A. Let's do part B. What is the standard deviation of the sampling distribution of X bar for the sample size of 100? So remember, this is sigma of X bar, which is equal to, oops, S divided by square root of n. So right here we found S to be 3. We found n to be 100, so you do square root of 100. If you do 3 divided by square root of 100, square root of 100 is actually is equal to 10. So 3 divided by 10 is 0.3. And that's all you have to do for part B. Everybody good for part B? All right, so let's do part C. So for part C, it says, what is the probability to attain a sample mean less than 9.6 days? All right. So let's go ahead and do that. So we want the probability that the sample mean of X bar is less than 9.6 days. So remember for this one, since this one we're using the t distribution, the reason why we're using the t distribution, because of this. So we are using the t distribution. All right, we're using the t distribution because we have a sample standard deviation. So what we have to go ahead and do, we're going to have to convert it into a t value. So to be able to do a t value, we're going to say 9.6 minus the mu, which is 9, and you're going to divide it by sigma of X bar, which we found it to be 0.3. So if you do 9.6 minus 9, you get 0.6 divided by 0.3. If you do 0.6 divided by 0.3, you get 2. So we're actually going to find the probability that t is less than 2. All right. Everybody good? How we got t is equal to 2. All right, so the last thing before we go over and start drawing this out, we want to find degrees of freedom. So for this one, what's my degrees of freedom? So yeah, so it should be 99, because if you remember, if you do 100 minus 1, you get 99. So degrees of freedom is 99. So I'm going to go ahead and draw this out. For that way we could see what's my lower bound, what's my upper bound. So you put the middle as 0. You put to the right is 2. And if you look at it, since it says less than, you shade the left-hand side. All right, so let's do the lower bound. Let's do the upper bound. So for this one, what will be my lower bound? What's the lowest value that possibly could shade on the left-hand side?
Negative
There you go. What about my upper bound?
2.
Perfect. All right, so right now what I'm going to go ahead and do, I'm going to go to class calc. I'm going to use a t distribution. I'm going to tell that we have a degrees of freedom of 99. We have a lower bound of negative infinity, but we also have an upper bound of positive 2. So let's go over and transition to class count. All right, so we go to stats, we go to distribution, we go to T distribution, we say 99 is our degree of freedom. We say CDF, so our lower bound negative infinity, so we leave the negative infinity alone and we change this to 2. All right, so if you look at it, we get 0.97588. So our final answer will be 0.97588. And that's it for C. Any question in regard to C?
No.
No, sir.
All right. So let's do the next one, and then I'll let you try out the last problem, and then we'll do some activity. All right, so let's do these ACT scores. So it says the scores of a student on the ACT college entrance exam in a recent year had a normal distribution with mean of mu equal to 18.6. The sample standard deviation is 5.9. So if you look right here, they tell us mu is equal to 18.6. But if you look at it, they say sample standard deviation is equal to 5.9. So if you look at it, since we have mu is equal to 18.6 and we have S, which is 5.9, for this one, we're going to have to use the T distribution. All right. So now for part A, it says now take a simple random sample of 50 students who took the test. What are the mean and the standard deviation of the sample mean score of X bar of these 50 students? So the 50 students, what does the 50 student, what does that represent? Like what symbol can I put to represent 50? I should put 50 is equal to what?
N.
Yeah, good, N. So we say N is equal to 50. So if you look at it, it says, what are the mean and the standard deviation of the sample mean? So all it's referring to is mu of X bar and sigma of X bar. So I just want us to find what mu of X bar is equal to and sigma of X bar is equal to. So mu of X bar should be pretty simple because it is 18.6. For sigma of X bar, it could be a little bit more complicated because remember, you have to do S divided by square root of N. S is equal to 5.9 divided by square root of 50. So let me go ahead and do that on my calculator. So I do 5.9 divided by square root of 50. All right, so if you do 5.9 divided by square root of 50, you get 0.83. And that's all A wants you to do. So if they just say find the mean and the standard deviation of the sample mean, all they want you to do is find mu of X bar and sigma of X bar. All right, but that's it for A. Any question for A?
No.
All right, let's do B. So if you look at it, what is the probability that the mean score of these students is 21 or higher? So we want to find the probability that the average of these 50 students is higher than 21. So before we could go ahead and actually find this, we have to convert it into a T value. So we have to do T is equal to X bar minus mu of X bar divided by sigma of X bar. So X bar is equal to 21. Mu of X bar is equal to 18.6. And actually, the standard deviation of X bar is equal to 0.83. So let's do 21 minus 18.6. You get 2.4 divided by 0.83. If you do 2.4 divided by 0.83, you get roughly 2.89. Everybody good that t is equal to 2.89.
Yes, sir.
So instead of finding the probability that x bar is greater than 21, we're going to find the probability that t is greater than 2.89. So let's go ahead and draw this out. So middle should be 0. Then you put 2.89. And if you look at this and it says greater than or higher than, what you want to do, you want to shade the right-hand side. All right, so for this one, what's my lower bound?
2.89.
3.89, perfect. What's my upper bound?
Positive infinity.
Other than infinity. Lastly, what's my degree of freedom in this case scenario?
49.
Yeah, good. 49. Because if you do 50 minus 1, you get 49. So we have everything that we need in order to put this into our class calc form calculator. So we have the lower bound, which is 2.89. We have the upper bound, which is infinity. And we have degrees of freedom, which is, yes, 49. So let's go ahead and go over to class calc where we can enter this. So let's go to that distribution, t distribution. We put degrees of freedom of 49. We put CDF, and we go lower bound is 2.89, and then infinity, well, you leave it as infinity. So our final answer will be 0.002, and we'll take 29. Okay, if you look at it, since it's 8 and 6, the 6 is going to round up the 8 to a 9. So that's it for the last problem. Any question for how to do this with class calc? All right, so we're gonna do one last problem, and then we're gonna do activity. All right, so what I want you to do, want you to work out this problem. So I want you to work it out, and I'm gonna put up a poll, so that way you could tell me what did you get for your final answer. So right now, what I want you to do is just work on this problem and see if you could do it. Let's see.
I have a question.
Yeah, what's up?
So when it's sample, for the standard deviation, we do t, right?
Yeah, you do the t distribution.
Okay, thank you.
Yeah, no problem.
Would my mean be 290 or would it be 300?
Well, technically both of those are your mean, but one of them is the population mean, one is the sample mean. So if you look at the 290, they say they got that from a sample because it says the sample bulb lasts on average 290. So that should be X bar to 290. 300 should be mu. Because if you look at mu, if you look at the 300 day, they don't tell you this is coming from a sample. They're telling you like this is what it should last.
Okay, thank you.
Yeah, no problem. All right, so those are your options. So let me do the poll. All right, so far we have 2 people for A, 3 people for B, 3 people for C, and 3 people for D. So essentially it's all over the place. All right, so let me share the poll with you. Let's end it and share. All right, so for A, we had 2 people who chose A. For B, we had 5 people who chose B. For C, we had 3 people that chose C. And after we had D, which 3 people chose, so 3 people needed help. Well, not everybody participated in the poll, so I'm guessing more people needed help with this problem. So for this one, the correct answer should have been A. So everybody, or the 2 people who said A, congratulations, you got it right. For B, or for people who chose B, C, or D, well, just kind of follow along as I do the problem so that way you can kind of see what went wrong. All right, so let's do this one. So it says the CEO of a lipo manufacturing company claimed that the average lipo lasts 300 days. So they're telling us mu is equal to 300 days. So it says a researcher randomly selects 15 lipo for testing. So that's our N. N is 15. Next, so it says the sample bulb lasts on average of 290 days. So if you look at it, it says the sample bulb lasts on average 290 days. So that's your X bar, the 290. With a standard deviation of 50 days, so S is equal to 50. So it said if the CEO claim were true, what are the probability that 15 randomly selected lipo would have an average life of no more than 290? So the keyword here is no more. So no more means it can't be more than 290 because it's no more than 290 days. So pretty much what this is saying, it's saying less than. So we're trying to find the probability that X bar is less than 290 days. So that's why some of you chose B, because you have the probability X bar is greater than 290 days. So for this one, you had to just figure out, since it says no more than 290 days, it actually means less than 290 days. So for the 5 people who chose B, that's why B was incorrect, because since you want it to be no more than 290 days, you want to say less than. All right, so let's go ahead and do this problem. So first thing we're gonna go ahead and do, we're gonna find mu of x bar, which is 300. We're going to find sigma of x bar, which is 50 divided by square root of 15. So if you do 50 divided by square root of 15, so 50 divided by square root of 15, you get 12.91. All right, so that's my mu of x, that's my sigma of x. So up next, I'm going to go ahead and find my t value, which is 290 minus 300, all divided by 12.91. So if you do 290 minus 300, you get negative 10 over 12.91. If you do negative 10 divided by 12.91, you get roughly negative 0.77. So what we're going to do, we're going to find the probability that t is less than negative 0.77. So instead of finding the probability that x bar is less than 290, we converted the 290 into a t value, and that's where we get the negative 0.77. Now let's go ahead and draw this. But any questions so far about any of the work that I have done? All right.
No.
So the middle should be 0. And since we get negative 0.77, negative 0.77 should be to the left of 0. So remember, we want it to be less than negative 0.77. So you shade the left-hand side. So for this one, we get the lower bound and we get the upper bound. So if you look at the lower bound, since it keeps going to the left-hand side, technically it's going to negative infinity. So for this one, we'll go to negative infinity. For the upper bound is the highest part that's shaded, which is a negative 0.77. And lastly, we have to find degrees of freedom. Degrees of freedom is just n minus 1, so 15 minus 1, which you get 14. So when I go over to class calc and I do the t distribution, all I'm going to tell her is, well, once I choose the t distribution, degrees of freedom is 14. Lower bound is negative infinity, and my upper bound is negative 0.77. So let's go over to class calc. What did I do with class calc? So to go to class calc, you go to stats, you go to distribution, and you go to t distribution. So degrees of freedom is 14. You do CDF. My lower bound is negative infinity, so don't touch that lower bound. My upper bound is negative 0.77. Wait. And if you look at it, you get a probability of 0.227, which in my problem, I just rounded it up to 0.23. But that's how you were supposed to get the correct answer. So like most of you got tripped up on the no more than 290. But pretty much for this one, you wanted to get 0.23 because since it's no more than 290, it means it should be less than 290. But that's how you do that last problem. Any question in regard to that last problem? All right, so let me show you what you're going to be working on today. So if you go to the syllabus, pretty much where we did this on Friday. So technically we're on Tuesday. So for today, you're going to take quiz number 15. So you're going to take quiz number 15, and that's going to be on sampling distribution of sigma known. And for today, you're going to do class activity number 17. And if you actually look at class activity number 17, it's pretty short. It has 2 questions. Let's see. So if you go to class activity 17, you only have to do these 2 problems, and then you're done. So once you do those 2 problems, just kind of flag me down or just private message me, and that way I'll be able to let you know if you got them correct or not. But these are the two problems you're gonna be working on today for your class activity. All right. Any question in regard to what you're gonna be working on in a little bit? Wait. For homework here, let me check your homework. Pretty much for the homework is the chapter 7 homework, the central limit theorem, but you should have already done that. So for this one, there's not really homework. If you already did the central limit theorem, you should be all good in regard to homework wise. All right, so let me break you up into your room.